And let's try to do an experiment to show you this optical spectrometer in action, where you can see the visible part of the spectrum and also a little bit of ultraviolet and quite a lot of what we call the near infrared, beyond what you can see red, and it's actually heat. To do this, I've only got two hands and I have to hold the computer out of the sun, otherwise you cannot see the screen. Let me put the spectrometer in my pocket. The entrance to the spectrometer is connected to this fiber optic here. Wonderful devices, fiber optics. I could turn them around and I could do this and light will still go through. Light is transmitted by a thing we call total internal reflection. So this is, the other end is connected to my spectrometer, and I'm now pointing that towards the sun, and you can see the spectrum on the screen. If I find more sunlight, this is an experiment, remember. There's the sunlight, there it goes. There you go. So you can see the company that made this been very kind to us, and they've shown us where is the violet, where is the red, and you can see beyond the red, the so-called infrared. That is heat. Below the violet is the ultraviolet, and there's a little bit there being shown by this spectrometer coming from the sun. It is not optimized for ultraviolet. Some spectrometers obviously designed are. There you go, there's the spectrum of the sun. It's very difficult to hold because my arm is now quite high in the air, but you see purple, blue, indigo, green, yellow, orange and red, the colours of the rainbow. This one records the data now to my computer here, and then I could use this small device not with the sun. Let me put my finger in front of there and you see that it goes away. Takes a bit of time for it to go away, but it will go away. It got stuck. Yeah, I think I put the computer on store. But it goes away. I put my finger there. It comes back. And I put my finger there, it goes away. This one transmits light from your light source to the spectrometer, which is in my pocket now. This is a real experiment we're doing here. And I found a good angle here by bringing the camera back. I found a good angle for the spectrometer. Now you can see the spectrum again. Yes, there you go. We can see some infrared and we can see some ultraviolet. This is a real experiment, me putting the spectrometer in my pocket, leading the light from the sun into the spectrometer with a fiber optic cable and showing you the infrared and a little bit of ultraviolet. If I were to use this with a lamp, take it away there, put my finger over the fiber optic cable and the spectrum disappears. If I were to use this looking at a hydrogen lamp, which Anders Ångström did 1864, I would see a red line very strong here, something in the turquoise here, and two in the violet. That is all the lines you see from hydrogen. He measured the wavelength. Here's the wavelength scale put for us by the very friendly company, but it is 700 nanometers, 0.7 times 10 to the minus 3 of a millimeter, and he's done all for you. Ångström had to do all this himself, and you saw one very strong line in red, one in the turquoise and two in the violet, and you can see exactly the same from the sun if I could hold the spectrometer steady enough, which I cannot. But anyway, these small devices can tell us about the composition of objects in space. This is a small device. This spectrometer here is a small device, not powerful. We have devices at least 100 times bigger, which can really tell you details of the rainbow, if you like, from the sun, with its various colours here and there. And we can look at any object in space and we can see what is it made from. That is the way we do it. Thank you.